Now let's talk about another part of this. Remember that AS in AS400 stood for application system. So let's talk about those applications. Now I'm going to step back in history again, back to that single level store. And remember, programming in single level store was supposed to provide significant value, and it did, it does. Okay. But back then, the programming languages that used that single level store in the very beginning were RPG and COBOL. It was great for that. Then came along already in V1 R2, the second release of the operating system, the support for the C programming language. And that caused yet another change. Why? Why? Because C introduced pointers. At the time, neither RPG nor COBOL had the concept of pointers, but if you know the C programming language, it is predicated on pointers. Everything you do is a pointer, which means there has to be an address. And that gets to be a problem because in the single level store, remember, everything is just an address into some part of storage. So your application and the things it's dealing with have a pointer to somewhere in the storage, long storage stream. And your operating system code is also running somewhere in that long stream of storage. So if you have a pointer that your application needs because you're running a C application, what's to keep you from doing some pointer math, adding a whole bunch, subtracting a whole bunch, and somehow ending up in somebody else's storage? Okay, which was certainly possible. What's going to keep you from doing that? Well, in the original AS400 release one, there was nothing that would keep you from doing that. So when we added the C programming language, we also had to add security level 50 and the initial hardware support for storage protection of pieces of the operating system that were deemed to be sensitive. Okay, so we had to create storage protection. We had to create this thing called privileged and problem state support. So the things that were in the problem state, which is essentially the application state, they could not generate a pointer and use it if it was being used by programs that were running in the privileged state. And we had hardware that helped us protect that. Okay, that got built into the processors that ran release 2 and later. And by the way, that storage protection that was invented in the second release of AS400 has been carried forward to the power processor. We continue to use that architecture, and it has modified over time. I actually don't have time in here to explain how it's been modified over time or how AIX takes advantage of it, but just trust me on this. As we've moved forward, we've had reasons to change this again and again. So when we're talking all the things that AS400 had, each one of them has had to evolve. I'll tell you a little bit about how the architecture of the platform has had to evolve over time based on how programming evolved. Now, those of you who've been on the platform for 20 years or fewer probably don't remember having to write software that was monolithic. But back in the early days of computing, it was very, very performance-wise expensive to have software that was in separate places and then had to call from one place to another. From a performance point of view and a storage point of view, it was very difficult. And so people wrote software in monolithic ways, thousands and thousands of lines in one single program. That's what we came from. Okay, but computers got to be considerably more capable of being able to do quick instantiations from one program to another. And so programming, particularly as PCs came into existence, personal computers, as they came into existence, the programming world changed to the point where people wanted to write things in much more modular ways. And computer architectures were helping clients to support and programmers to support this whole level of modularity. And so AS400 had to invent a way to make it better on our operating system. And so we created this thing called the ILE. It was also somewhat colloquially known as the new program model, which differentiated it from the original or old program model. But the new ILE program model came into existence. And I'm showing you which parts of the architecture here this is talking about. Okay, because before the introduction of ILE, resources like open files and so on that were used by a program could only be scoped to the program or the job. Okay, there was no way to share them across things. ILE offered a third alternative that allowed you to create a group of programs that all had access to these things at once. So it certainly could be a program, it could be a job, or it could be this activation group. And as you created more modular pieces of code, you didn't have to have it all running within a program. And the job wasn't efficient enough. If you created an activation group, you could share these resources much better. And so we had this concept of an activation group that had to get added to the architecture. Once we did that, we were able to have these modular pieces that could act as if in memory they were all connected to one another, so that when you loaded them, you weren't loading one monolithic piece of software. You were loading the pieces that were in the activation group that then had easy access to all these resources. It also made it possible for people to create and use modules which are reusable, easier to debug, easier to add to in every way that it is on every other platform. But we had to create an architecture on IBM I that would allow us to do that. So that was part of the evolution that had to happen to allow us to move into today's modern modular programming environment. There was another thing, however, that was happening, and that was, where do you run your programs? Architecturally, how does the operating system manage that running program? We had jobs in the original AS400 architecture, still exists today, of course, there's still jobs, okay? And within that job, there was a process, which was the implementation of the job um, in, in the rest of the operating system. It was fine, that was well and good, but in comparison to other architectures, setting up this job, which has a huge amount of information about the resources that are available to you and so on, and setting up the process that supported that job, comparatively to other things that were going on in the industry, they took a long time to set up. Well, applications were beginning to be written not just modularly, but sort of asynchronously. They wanted to be able to kick off a piece of work asynchronously, have it do that work, have it report back, and then move on with what it needed to do. And they wanted to do that. Applications wanted to do that frequently. Well, that meant that you had to have a new thing in addition to jobs and processes. And in the industry, those things were threads. This was one of those times when the industry and the technology that was going on forced us to adapt and be able to keep up with how people were doing programming. So we had to create threads. Well, we had a particular application out there in the world that wanted to be able to use threads. The thing was, we had implemented threads as a one thread per job thing. That meant every time you were doing a new thread, you were kicking off a new job, and that was a mess. It was just a mess. Lotus Notes was the application that we wanted to get running on AS400 and then I series. So much of the competition that was happening on the AS400 and then early I series was because people were putting email servers from other vendors into their organization and then making people think that, well, since they use that platform for email, they should use it for other things. We said, if we can get an email application on our platform, we could help fight that off. And of course, it needed not just one thread per job, it needed nice, high-performing threads. And so we had to create a threaded environment within IBM I that would support that. And now that sets us up to be able to do multi-threaded programming that can compete at a performance level with other things that were going on. And of course, Lotus Notes was super successful for a very long time on this platform because we implemented this thread-based architecture and the product used that. It was not, however, the only thing that took advantage of it, because another thing that came along during that time frame was web serving. The hypertext transfer protocol came into existence. This, by the way, is a picture of the very first web page that was ever created and served up by the CERN web server.